Assalamu alaikum wa rahmatullahi wa barakatuh. Today, inshallah, we're going to answer the chemistry revision pack. So let's start. Okay, so in this question, they are investigating solids, liquids, and gases. So what is the property here that they are investigating or that they are testing for? This compressibility, because they are going to push the plunger down and see if the substance can be compressed or not. So this property is compressibility. Okay, why did they block the tip of the syringe? They blocked it so that the sample won't escape out of the syringe. So you cannot say in this case so that the air will not escape out of the syringe, because he's using different substances, solids, liquids, and gases. So you're just simply going to say that to prevent the sample or the substance from going out of the tip of the syringe or from escaping out of the syringe. Here is the table that they they chose that when they did this experiment on water and wood, the plunger stayed in its place, but the air and the unknown material, the plunger went in. So identify the material that is a gas. So it's water. I'm sorry. It's air and the unknown material. Why? Because the plunger went in. So this means that it's compressible and only gases are compressible. But the question is out of three. So how are we going to take the 3 marks? First of all, we're going to take a mark on the identification. So when you say air or unknown material, you're going to take 1 mark. Okay, give a reason for your answer. It's out of 2. So you're going to say that the plunger went in case of the air and the unknown material. That's why the substance is compressible and only gases are compressible. Okay, you're going to specify the reason why gases are compressible, because there are spaces between the particles, so you can push them together. Explain a further test you would need to carry to determine the state of water. In this experiment, they did that it stayed in the same place. So another experiment that you could do to make sure that it's water, it's either that it flows or it takes the shape of the container. So if we said that the water takes the shape of the container, it's out of 2. So you're going to describe how are you going to do the experiment. So you're going to say that you're going to pour the water in any container and it's going to take its shape. This is how to take the 2 marks. First say the test and then explain how or describe how you're going to do this test. I want 2 differences between boiling and evaporation. It's out of 4. So um, one of these 2 differences, you can say that boiling, it occurs only at the boiling point, while evaporation happens at any temperature. Also, boiling occurs to all the particles, but evaporation only happens or occurs to the surface particles only. You can also say that boiling is faster than evaporation. Okay, then, okay, number 3. The girl has just done the washing and now she's hanging out her clothes in the sunshine. When she comes back after a few hours, her clothes will be dry. So, explain what happens to the water in the wet clothes. It's out of 3. When he tells you to explain, you have to describe and say why. So, in any explanation, you have first to describe what's happening and then say why. So, here the water, what happened to the water? So, the water evaporated. Okay, why did the water evaporate? It's out of 3, so you have to mention 2 things. You're going to take 1 mark for writing the water evaporated, and then 2 things for the explanation. So the water particles gained enough energy from the heat of the sun, okay, and that's why they're going to move freely, so they escape as water vapors. So 1 mark for gaining, the particles will gain energy from the sun. The second mark is the particles will move freely and escape as vapors. Okay, you're going to choose from the word bank. So which 2 words describe a metal cable? It's a good conductor of electricity and malleable. Of course, if you don't have word bank, it's better to write the word ductile, because ductile is more specific, as ductile means you can stretch it into wires, but malleable, it's any shape. But as long as we don't have ductile in the word bank, so we're going to write malleable. Two words to describe a glass window: it's brittle and transparent. Brittle means um, it's going to break down suddenly if you hit it or you bend it. Complete the sentence. A cooking pan has a plastic handle. This plastic is an insulator of heat, so you won't get burned. Read the description and then tick. It fills the space and can be compressed. It's a gas. It's the only material that can be compressed. It's brittle and it conducts electricity. It's graphite. Why didn't I choose metal? Because metals are not brittle. They are hard. But graphite, it is the only non-metal which is a good conductor of electricity. Okay, the plastic is an insulator. It's opaque or transparent. It's a good insulator of heat and electricity, and it's flexible. So of course it's plastic. Make sure that you know that all the metals are good conductors of heat and electricity. Okay, which symbol would you suggest that the substance should be kept away from heat? It is the second one, which is the flammable hazard symbol. Okay, what is the difference between hazard and risk? As we said before, a hazard, it's anything that can cause harm. So it is a potential problem, a problem that could happen. For example, the stairs is a hazard because you can fall off while you are going up the stairs. Okay, the risk, it's the chance of the harm caused by the hazard. So here it is the likelihood, the chance, the probability of the harm or of the problem caused by the hazard. If you're, مثلا, for example, going up the stairs quickly, if you're rushing, then you are at high risk of falling down. If you are uh, going up slowly, then you are at a low risk of falling down. And at the end, there are the precautions, which are the safety measures that you should do to reduce the risk. For example, when you go up the stairs, you shouldn't carry a lot of stuff. You should go up slowly, be careful. All those are precautions that you should do. So in the exam, if he said mention a hazard, you have to say the thing and the harm that it can cause. If he asks for the precautions, you should say what to do, the safety measures that you should do to reduce the risk. Okay. A chemical reaction that produces a decrease in temperature, it's the instant cold pack. A decrease in temperature, this means that it's an endothermic reaction, because in endothermic reaction, the reaction takes in or absorbs heat from the surrounding, so the temperature of the surrounding decreases. And as I said before, we don't measure any temperature except the temperature of the surrounding. So when the temperature of the surrounding decreases, this means that it's an endothermic reaction. The example here is the instant cold pack, and the first surrounding is what is inside the pack. Okay. Safia and Mia are mixing citric acid with sodium hydrogen carbonate solution. So the starting temperature was 20 and the final was 7. So this temperature decreased by 13 degrees Celsius. If you're measuring the temperature change, it will be negative 13. But as long as he said decreased, so you're going to write 13 degrees Celsius, and that's it. Okay, so what was transferred from the surrounding? It's energy, and this energy is usually as heat energy. That's why we call it endothermic or exothermic. Thermic comes from the word heat energy. Okay, Yusuf is investigating the changes of the magnesium ribbon when added to hydrochloric acid. So here he's changing the length of the magnesium, and he's measuring the temperature at the start and at the end. So what are the conclusions? It's out of 3. So first of all, you have to mention that the reaction between the magnesium and hydrochloric acid gives out heat because the temperature increases. So Because the temperature increases, this means that the reaction gives out heat, and this means that the reaction is exothermic. So this is the first mark. The second mark, you have to say that as the length of the magnesium ribbon increases, the temperature rise will increase too. Don't say that the temperature will increase. The temperature increases in all the cases, but the rise will increase when you increase more the length of the magnesium ribbon. So when you use a longer magnesium ribbon, the temperature rise will increase. As you see here, the temperature increased by 0.8 degrees Celsius only. But if you use a longer magnesium ribbon, the temperature will increase more. In case of 2 centimeter magnesium ribbon, it increased by about 1.4 degree Celsius. So the rise increases more. Okay, which of the following is an endothermic process? It's photosynthesis process. Photosynthesis means it's endothermic because the plants absorb, takes in sunlight energy. Okay, freezing and condensation are exothermic. Also combustion, which is burning, it's exothermic. It gives out heat more than it takes. Okay, in freezing and condensation, remember the rule X, Y, Z. So exothermic, an example of it is freezing, and freezing is like condensation. Okay, let's complete the words. Exothermic process transfer energy to the surrounding. It gives out energy to the surrounding. This energy is often as heat energy, so the temperature of the surrounding will increase. I don't measure a temperature except the temperature of the surrounding. Again, this is very important. But in endothermic processes, this process um, absorbs energy from the surrounding, so transfer energy from the surrounding, and the energy is usually heat energy. If you're going to match, so uh, melting and evaporating are endothermic, freezing and condensation are exothermic. As I said, X, Y, Z. So exothermic goes with freezing, but endothermic, MN, so melting is endothermic. If I'm going to choose one of the examples, for example, why freezing is exothermic, so you're going to think that freezing is the change from solid to liquid. So you're going to see if heat is absorbed or heat is released. In freezing, when you change from solid, from liquid to solid, I'm sorry, freezing it's from liquid to solid. So when you change something or a substance from liquid to solid, the heat is released. The heat goes out. For example, if you're changing water to ice, the heat goes out to the surrounding and forms ice. So as long as the heat is released, it's exothermic. If you're going to have this um, heating curve, so what is the temperature at the start? It's minus 10. As you see, it started a dash below the zero. It's minus 10 because each dash is 10. For example, 0, 10, 20, 30, 40, and 50. Okay, what is the temperature of at which temperature did the ice melt? It melted at 0 degree Celsius. The first plateau shows the melting of ice. Here, the ice starts melting, and here, all the melting is done. So all the ice changes to water. Explain what's happening to the particles during step 2. Step 2 is the melting point. So what's happening here? All the heat energy added is used to overcome the forces between the particles. So the particles use the heat energy to overcome the forces between them, and the ice melts. So the particles will start sliding past each other, and the regular pattern will be broken. It's here when you're removing the sticks. So the pattern is broken and the particles will start to slide past each other. So I want here to name the type of energy change in step 4. This is boiling, so the energy change is endothermic. Why the energy change is endothermic? Again, I'm going to see boiling, it's the change from liquid to gas. So heat is released or absorbed. No, in this case, heat is absorbed to turn liquid into gas. The heat is absorbed. Why? To overcome the forces between the particles and turn liquid into a gas. So the reason is that the particles absorb the heat energy to overcome the forces between them, and so the liquid turns to gas. Okay, so that's it for today. Thank you very much, and see you next time, inshallah.